sorry. So you have this acidic reaction taking place in presence of hydrochloric acid. So the ribose content, the sugar is ribose in case of RNA, right? In case of DNA, it was deoxy ribose. So there, sugar is going to react, and when it reacts with orcinol reagent, it will give you a furfural. Okay, so furfural, which is going to further react with your dihydrotoluene in presence of ferric chloride, which is your orcinol reagent, and that gives you a green colored compound. Okay, that green colored compound. So similarly, matlab jaise we found out blue colored complex in case of your DPA method, here we are going to get this uh, your green colored compound, and which can be absorbed red at 665 nanometers. So purine nucleotides are generally more reactive than your pyrimidine in this your RNA. So the absorbance, as we had seen, is going to be directly proportional to the concentration of the sample. Hence, the concentration of the unknown could be obtained in the similar way by plotting a graph with concentration on x-axis and absorbance on y-axis. Okay, so this is your orcinol reagent. 1 gram of ferric chloride can be dissolved in 1 liter of concentrated HCl, and then to this we have to add your 35 ml of 6% orcinol in absolute alcohol. Okay, so RNA is diluent. Diluent here will not be using distilled water. In DNA, we use distilled water, hence, or we dissolve this DNA in distilled water, hence the diluent was also distilled water. Here we are dissolving in 10% trichloroacetic acid, so hence that would be our diluent. So here this is your 100 micrograms per ml is the standard concentration of the RNA that you are going to use. So in a similar way, जैसे वहाँ पे table था वहीं पे this is your concentration. You have 20, 40, 60, 80, 100. So as I have already explained you, by the help of your RT by G method, you would be finding out how much amount of this, volume of the standard RNA should go. So for like I explained you in the other video also. So for 20, so 20 is your required concentration. What is your given concentration? 100, because you are using 100 as your standard RNA. So 20 upon 100 is 1.1 upon 5. Total कितना हो रहा है हमारा volume, that is this plus your TCA 2. So total volume is 2, and hence you will be finding that it is your 0.2 is your volume of your standard that is going to be used. So this is how the tube will look like. This is your blank giving you yellowish color. So here you can see that the reagent also has a color. So that reagent color is also a part of the standard tube which needs to be negated, and that is the reason why we are doing that blank ko hum tear karte hain, we make it as 0. Yes, so that means you are minusing, you are negating this color of your blank from all your standard as well as your test tube. So this is how the color will look like. Yes, you can take your OD and your concentration, plot a graph, and then you will be getting. So as we are doing it on a graph paper, you can also do it on Excel sheet. So Excel sheet mein whenever you get a graph, you can get the you can find out what is the equation of the straight line graph that you are getting. From that equation, you can find out what is the concentration of your unknown. Okay, so that some other day I'll explain you how to do that particular thing. But for you, you have to do it on your normal graph paper only, and it is the same way as you have done it for your DNA. Okay. So again, I have one YouTube video to show you how to do this estimation part. Okay. So this video, yes, I have not shooted. Okay, it's because it's going to be the same like your DNA by DPA. So I have not shooted that experiment, but this is available on the YouTube, and that is what I am going to show you over here. Okay, so just give me 1 second.
So let's see how the experiment goes. First we are having the standard RNA solution, the unknown RNA solution, distilled water and Orcinol reagent. We are taking electrodes as 0.2, 0.4, 0.6, 0.8 to 1. In the blank we don't have to take the electrodes, so in the first standard tube I will take 0.2 ml of the standard RNA solution. Then in the next tube 0.4 ml of standard solution. Now in my pipette I am having 0.4 ml of standard solution. I will put it in the 0.6 ml tube. Now we have filled the tube with 0.4. Now I will add the left 0.2 ml of RNA to make it up to 0.6. On my pipette I am having 0.8. And the last standard electrode tube we will take 1 ml of standard RNA solution. So we are done with the electrode of the standard. Now we take unknown RNA solution. We are taking electrode of 0.4 and 0.6 ml. So now we have filled the electrode. Now we will just make the level of all the electrodes and the unknown tubes to 1 ml. And for that we are using distilled water. For my first electrode I am taking 0.2 ml of standard. So now I will add 0.8 ml of distilled water. The next tube we have 0.4 ml of standard. So I will add 0.6 ml of distilled water. Then I am having 0.4 ml in my pipette and I also need 0.4 only. So I will add 0.4 in the third electrode. Now in the fourth electrode, we take 0.2 ml of distilled water. And in the fifth one, we have 1 ml of solution, so we don't need distilled water. But in the blank, we have to take 1 ml of distilled water. Now we add distilled water to the unknown solution to make its level also to 1 ml. We have 0.4 ml of our unknown RNA solution. So I will add 0.6 ml of distilled water. Next one we have 0.6 ml of unknown RNA. So I will add 0.4 ml of distilled water. So now all are now at a level of 1 ml each. Now we have to add our Orcinol reagents. Our reagents are actually the concept is that ribose sugar in very acidic condition gets converted to furfural, which then reacts with our reagent Orcinol and it gives a green color complex at 665 nanometers. So now we have to add our reagent to all the tubes in equal amount, that is 4 ml. And similarly, we fill all the tubes with 4 ml of our reagent. All our tubes are having the equal amount of reagents and green. All the rest tubes should have 1 ml of sample. So now all of these are having the same amount. Now we have to incubate it in boiling water bath for 10 minutes. As I said, the Orcinol, we have added the acidic condition. We have added acid in the reagent already. So the conversion of ribose sugar to furfural has started. And now when we keep it in the boiling water bath, it will start reacting with our reagent Orcinol and it will start to get the greenish color, standardize our RNA sample. Now we have to keep all the tubes in boiling water bath for 15 minutes. Let's see whether the color is there or not. Here we can clearly see the color, the complex color. As the standard concentration increases, the color intensity has increased. And by comparing the standard with the unknown, we can now get the concentration of the unknown sample.
Yes, students, this is how you are going to estimate the RNA in your sample.